Welcome back to another video for the 2022 AP Calculus AB for response portion. And here we're going to talk about number 2. This is the calculator allowed question, calculator required question. You have two functions. The natural log function will be this one here, and the polynomial will be that one, just given the way it looks. You can always graph to verify. And they intersect the -2 and then b, which we don't know. So we'll want to find that right away. And of course, they say b is positive. So find the area enclosed. So let's find the x coordinate there, but definitely going to have -2 on the bottom. And definitely you're going to have f of x as the top and g of x as the bottom. So that's really easy. And you can actually just write like that because it's already labeled as f and g. So you don't have to actually write the functions, but you are going to have to type that in your calculator for sure. My guess is probably worth 1 point on the AP exam. Because it's a pretty easy problem. Maybe 2 points to find the upper limit and then setting it up and getting the answer or something like that. Highly doubt this will be worth 3 points. So we're going to go and clear what we have from the previous problem. And just to get this stored right away, because we're going to have to reuse these many times throughout the problem. Natural log of x plus 3. And of course, x to the 4 plus 2x cubed. Okay, there we go, got them stored. We do have to see where to intersect, and I'm gonna just change my window to zoom standard. I mean, you can make the window they have here, but I'm not gonna go with those big numbers from the previous problem. And let's find the point of intersection. So you go option 5, get close to it, hit enter a few times, and we get 0.782. So that's at 0.782. Comma 1.330. Okay. So obviously our upper limit is going to be 0.782. Not that hard, right? And that's already stored as x. So if I quit, hit x, you see it's already stored like that. So store that as alpha a. Perfect. And then you're going to make the integral. So go alpha window, fn int. Obviously doing -2. The top is going to be alpha a, so it's accurate. Doing alpha trace y1 minus alpha trace y2 dx, and let the calculator do its magic, and there you go. So easy points, 3.604. So that's that one, and there's no units here, so don't worry about that. Then part B, what's part B asking us to do? Part B is asking us to let h of x be the vertical distance between f and g. Is h increasing or decreasing? Well, we just did that. I mean, that's fx minus g of x, right? H of x is just the difference between those two curves, right? F of x minus g of x. So what the question is asking for is that distance increasing or decreasing at -0.5. So you're going to have to find h prime of -0.5. That's all. So you go back to your calculator. You go alpha window, but you're going to do n deriv dx, and of course you're doing alpha trace y1 minus alpha trace y2. Plug in -0.5, and again let the calculator do its magic. So you get -0.599 repeating. That's not too hard, right? That's pretty easy. You can also round up to -0.6000. That works too. So that's the answer, -0.599 repeating, or the College Board would accept this as well. So it is decreasing at that moment. Okie dokie. Then part C, what's part C want us to do? Part C is saying, hey, the region enclosed by the graph of FG is the base of a solid. So this is a volume problem. Cross sections are square. So you basically have a square like this. So that's one side of the square that's on the page, and then you have 3 sides are jumping out of the page. And you have a bunch of squares from left to right, right? So you're forming this interesting solid here. And find the volume. So remember, we talked about this many times. You just integrate from your far left to the far right. So -2 to 0.782, which we already stored as a, which is good, we did that. And then the area of a square, you should know is s squared, right? And that's s, right? That's one side of the square. And that side is what we did in part B, right? Just f minus g. So you're doing f minus g squared, right? It's because when you find the volume, it's going to be from a to b of your area in terms of x dx, right? That's how you find volume by cross sections. So our area again is s squared, where s is just f minus g squared. So that's what we do. Or in our case, y1 minus y2 squared dx. So again, we just type that into our trusted calculator. Alpha window, option 4, -2, go up, that's alpha A. And then I'll put an extra set of parentheses, alpha trace y1 minus alpha trace y2, and the parentheses, square it, dx. And there we go. You get 5.340. So again, a lot of calculator work, boom, boom, boom. Not too hard. That's what we get for that one. So it's a volume for part C. And then finally for part D, that one's a little funky. Again, just like the previous problem, the last part could be a little strange, you know, but just, you know, don't freak out. In the vertical line, the XY plane from left to right along the base of the solid described in part C. Okay, so again, they like these vertical lines. Okay, that's fine. It's moving from left to right. Okay. And the vertical line is moving at a constant rate of 7 units per second. Okay, so it's moving from left to right. Find the rate of change of the area when the line is at -0.5. So this is a related rates problem, totally related rates. And remember, our area formula was just f minus g squared. Or another way you could think about it too, is like that, where the side, of course, is f minus g, right? Because you're looking at the side of the square. Well, if you think about it, that's going to be 2s times ds dt. And of course, it's a prime of s, or sorry, dA over dt, because you didn't respect to t. So dA over dt. And they want the change in area. Well, here's the deal. We do need the side, the length of the side, -0.5. So basically, you're going to do 2 times f of -0.5 minus g of -0.5. So you need to find that vertical distance. And then the derivative. But we did do the derivative in part B, right? We just did that. We know it's -0.60 repeating, right? Actually, hold on one sec. Oh, never mind. It's moving at that rate. Got it. So we're actually going to multiply it by the vertical line is moving at a constant rate. Yeah, that's what we need to do. And then we just work it out. Yeah, sorry, my apologies. We'll get a little brain freeze there. But yeah, it's moving at that rate, 7 units per second. So yeah, we just work that out and we get the answer. And so if I do that correctly, so see your alpha trace. Actually, I'll just do it in my calculator. Well, you do it really here real fast. So go alpha y trace y1 -0.5 minus alpha trace y2 -0.5. And then if you times that by 2 and 7, you get 15.45. And there you go. That's how the area is changing at that moment. And they didn't give us units, so don't worry about it. So there you go. That is number 2.